Hi everyone. So today we will be talking about Git version control. Not in a lot of details, but the details which will be needed for a typical data engineering job, right? So before we talk about Git, let's talk about what version control is and why it is needed, right? So when we talk about a version control is important to keep track of the changes and keep every team member working of the latest version. You should use version control software for all code file asset that multiple team members will collaborate on, right? So what does mean? So in typical development environment, how your team looks like, and I'm just talking about any typical data engineering team, same applicable for any team, right? So your team looks like this. So you have some manager, and then you have 4 or 5 data engineers working on a typical team, right? So let's say we have 4 data engineers team, and let's say we are developing some end-to-end pipeline. End-to-end pipeline means that okay, extract data from somewhere, transform it, and to load it somewhere, right? Maybe for extraction we used Scoop, for transformation we use Spark, and obviously for load, let's say we use Spark as well. And let's say this data engineer 1 is working on a Scoop script. Data engineer 2 and 3 are working on transformation part, because obviously transformation needs a lot of effort. And they are working on some script called, let's say, transform.scala, right? Now, let's say these two people want to work on the same script at the same time. So what is the ideal way of doing it? What's the easiest way of doing it, right? So what they can do, they can make a separate copy of this script. He will download the D2 will download a script to his machine. D3 will download script to his machine. Then they will start working on it, right? And then at the end of the day, they will say, okay, I made these changes, I made these changes, and then they will merge it and save it somewhere, right? So this is the easiest path. So let's say D2 added 4 lines related to, let's say, some joining, let's say 4 joins, right? And then D3 added 4 group by operations, something like this. At the end of the day, they merge this thing, and then they save it to, let's say, some machine, some common server. Now, what are the benefit of this approach? Seems very simple, right? But in reality, these 4 joins, these 4 group by operation, they will be doing a lot of this kind of operation throughout the day, right? And at the end of the day, it will be very hard for them to merge. And then when they come tomorrow and they start working on it, they don't know whether they are working on the latest copy or not. Like, this is the typical example for 2-member team, 4-member team. Let's assume that you have 100 members team. How you gonna maintain the version of your files, version of your software, version of your different scripts, right? And this is where version control system comes in picture. So now let's go to version control system again, the definition. What version control system is? Version control is important to keep track of changes and keep every team member working on the latest version. I will cover it, how they will be working on the latest version. And we should use version control system or software for code files asset, in multiple team members where they can easily collaborate on, right? Now, what can be the benefits of version control system? The biggest benefit of any version control system is it will point to a single source of truth, whether we are talking about code or assets, right? One more important thing which I want to talk about, let's say you logged in at 9 a.m. You open the file, let's say test.scala, right? You made some changes, you save this file at 10 a.m., right? And then you started working on it again. But suddenly your code stopped working because of any reason. Maybe you dropped some line, maybe you messed up something, right? Now you know that at 9 a.m. your code was working. So how to track back to that particular code? So what version control system do for you? It will take the backup, which we can call a snapshot, which we can call commits, different software use different languages, but what you can do, you can go to the previous version, right? And every version is a kind of you can go to any version easily. That's simple, right? So the traceability for every change, can be easily achieved. Now the third important point is speed of the development. Obviously, so these all points, right? Single point of truth, traceability, collaboration. Obviously, these points will contribute towards the speed of development. On a single file, multiple people can work together. At the end of the day, they can merge their changes automatically, right? I will cover that in detail, but this is the thing. Now, what we should look and what is the major benefits in any version control system, right? So the first thing is concurrent development. What it means that multiple people can work on a single file and they can collaborate and they can check in, check out, and they can work together on the same file, right? Now the second thing is automation. So what we can see in this example, when the people are logging in at 9 a.m., they're making some changes. They are committing their changes every time, right? So what it means, let's say at 1 p.m. in the evening, I want to deploy all the changes. So what we can do, we can take the baseline at 1 p.m. It means all the committed code before this will be kind of put in some directory, and we can put the directory into production. Simple, right? So it means since people are committing their code, they're saving their code into some central repository. So it means automation. It means the deployment of this code into production is very fast. So concurrent development is first benefit. The second is automation. The third is team collaboration. And again, I'm emphasizing on team collaboration again and again. So it means multiple people can work on single product, a single file, single source code, and they can work together, right? One more thing is, let's say, and this is a very good example here. So let's say your team is spread across the world, right? Somewhere, someone is working from US, someone is working from India, someone is working from Ireland. So let's say other team member join from Italy, right? So how do we need to share code with him? So what we can do, if we have some version control system, what we can do, we can share the link to him. He can download the latest code and start working on it. And this is where the team collaboration really comes in handy, right? The fourth point is it's very easy to track changes, like who, what, when, why. Like whenever we are working with any version control system, what it means that, let's say we have a 5-people team, right? And we are working on, let's say, same file. And now what happens that I'm working on, let's say, some extraction logic, somebody is working on transformation logic, somebody is working on cleaning logic. So what we can do, whenever we are making some changes to this file, right? What we can do, we can commit our changes and we can put a message there that, okay, I'm committing ETL logic 1. Then other people can commit, I'm committing cleaning logic 1, something like this. At the end of the day, because of this version control, if there is a conflict, if the file or the code is not working, we can come to know at what time, till what time it is working, and after which commit it stopped working. And this is where these 4 things will come handy: who did it change, what he did it, when he did it, and why he did it, right? So it's very, very easy to trace the changes. Last thing is disaster recovery and high availability. So different version control system has different way of providing the high availability. Right now, the trend is going toward distributed storage or distributed computing. So there are distributed version control system available in the market. But even in any system, right? Let's say we are talking about client server model. So let's say we have one client, we have one server, and we have multiple clients connected to it, right? On this server, we are maintaining the central repository. So what we can do and what people will be doing, that they can be taking the backup of this server again and again, right? So this client, what they are doing, these clients are nothing but our data engineers. They will be checking the code, latest code from here. They will be making the changes, and they will be committing back to again to the server. And then this server, we can run a periodic job which can take the backup. But obviously this is not the ideal approach. The ideal approach should be that each data engineer or each machine should have their local code repository. It means local code which they can store on their machine, and this code repository, which we call R, should be on everybody's machine. So let's say if this machine is gone, shut down, what this guy can do, he can download the code, latest code from anywhere, either from some remote directory or from anybody's machine, right? So this is how we can achieve different benefits from version control system. Again, there are 4 benefits, 5 benefits: concurrent development, automation, team collaboration, tracking the changes, and high availability, right? So now the question is, what are different softwares available for version control? There's so many softwares available. One of the software which around 80% of technical people are using is called Git. Now let's jump to Git, what Git is, right? So in very simple terms, Git is a software for tracking changes. Nothing very fancy. We have covered in last 5 minutes. In any set of file, usually used for coordinating work among programmers, collaboratively developing source code during software development. Its goal include speed, data integrity, support for distributed non-linear workflows. Don't worry if you're not getting. So what it says, that Git is nothing but a software version control management system, right? VCS, version control software. So what is Git? In very simple terms, Git is version control system, right? Now what they are saying, that Git is a version control system, but it is distributed, right? Now what distributed means? Distributed means that this software is running on multiple machines, right? So we have M1, M2, M3. So it means this Git, into Git we don't have any in Git we don't have client server model, right? So what it means, that every machine has its own repository. It means every machine has its full set of code which they want to work on, right? So it means Git is distributed and every machine is interconnected to each other, and every machine has its own set of repository. When they want to commit anything, they will commit to their local repository, and at the end of the day, they can collaborate with each other. So how Git looks like? Gits look like something like this. So if you see here, there is no master or slave architecture here. So these are different developers, right? They have their own Git repo. Repo is nothing but repository. Repository is nothing but what you can call your source code or your directory of source code, something in which your code or files are stored. And every software developer or every developer has their own Git repo. This is called distributed software configuration management, something like it, serious. Now there's other type of what I can say, VCS, version control system. It means we have some client which has its repository, and what developers are doing, they're downloading their repo from that client, and this is called client server model. Every what I can say, every model has its own benefit, but to be honest, everyone 85% people are working towards Git, right? And they're migrating to Git. Why? Because obviously we know that distributed means high availability, right? Disaster recovery can be easily done. It is fast, because when you work on something local, it's very fast because you do not need to download code again and again. And this is where people are using Git, and so many benefits which we can cover in a lot of detail in the next 15-20 minutes, right? Now let's think why and when the Git is developed. So the Git real development began in 2005, and the inventor or the developer of the Git is the same person who developed the Linux kernel, right? So basically, what was if we look into the history, in year 2005, there's a team who is working on Git development, sorry, Linux kernel development, and they are using a software called BitKeeper. And this software was a proprietary software, not free, but the owner of this software, who is Larry McVoy. So what he actually made this software free for the Linux kernel development team. Now, what happened in year 2005? Some rumor or maybe some controversy happened that this guy Larry McVoy said that one of the developer of Linux kernel has reverse engineers the BitKeeper code and trying to create its own software, right? So what he did, this guy Larry McVoy, he said no, this software now won't be free for Linux kernel community. You need to pay for it. Now the main developer of Linux kernel, right? His name was Linus, Linus. So what this guy did, okay, see, I don't want to pay for it. And then what he did, he tried to look into the market and see which software are equivalent to BitKeeper. But what he find out that, okay, there is not even a single software which is fulfilling all its needs. So what are his needs are? He said, I need a software that can do concurrent version system, that can take the concurrent version system as an example of what not to do. So basically, there was a software called concurrent version system. He want to create a software which is exactly opposite of this software. He want a system like BitKeeper, which is distributed. And at the same time, he want to have a software which has a very strong safeguards against corruption. It means it should have some checks, some logic, and it should have some logic which can prevent the files from corruption. So in year 2005, he was unable to find this kind of software. So what he did, since he want his community, Linux kernel development community, to develop to collaborate and to do not need to worry about check in, check out, or code maintenance. So what he thought, okay, since none of the software is available, let me develop my own software. And he start working on Git development in April 2005, and it is written somewhere that he developed Git in 1 week, right? So now we know that one guy called Linus, who developed the Linux kernel, developed the Git software in 1 week, and the purpose of that software is to use that software for version control of the Linux kernel, so that different software developers who are working on Linux kernel development can collaborate the code, right? And so in 1 week, he developed the software, and this is the history of it, right? Now, we came to know that this software, Git, was supposed to track Linux kernel. So it means, and when I show you the Git, you will feel it that, okay, it has lot of resemblance with Linux file system or kernel file system, I can say, right? So this is all about the history. One more thing which I need to cover, and how this Git name came in picture, right? So what is the full form of Git? Is there any full form, or like how this name came in picture? So there again a theory about it, that, okay, this guy Linus, who developed the Linux kernel, tends to name the software on his name. So he named Linux based on his first name, Linus. Now what he said when somebody asked him that, okay, why you name this version control system as Git? Git means in a plain English or English language, Git means proudy or unreasonable person, or a mean person. So what Linus says, Linus Torvalds says that, okay, I love myself, I will name the software on my name, and I'm kind of a self-oriented person, so I want to name the software as Git. Nothing very fancy, but if somebody want to ask you that, okay, what's the full form Git, there's no full form Git, right? Simple. Now we know that Git has three properties. The first property is it is opposite of concurrent version system. You can read about it in Google. It's a very, very easily, can be easily get from the what I can say, Wikipedia. The second thing is it's more of like a bit keeper, which is distributed. And the third thing is it has a very strong safeguards using some checks and mechanism, right? So these 3 points. Now let's see how this guy Linus made it distributed and how it's different from the typical client-server distribution. So what it says, as with most of the other distributed version control system, unlike most client-server system, every Git directory on every computer is a full-fledged repository, and with complete history and full version tracking abilities and independent network access to the central system. What, in very, very simple terms, what he's saying, that in Git, obviously we are talking about distributed systems, so we have different machines, right? We have different machines, and let's say these machines are connected to each other, but every machine has its own repository, and this repository is full-fledged repository. It means we can say that every machine has full source code, full code, whatever you're working on, with complete history and complete version tracking abilities. So it means, so let's say the same example, abc.txt file, how it came from, let's say, from version 1, we changed something to version 2, version 3, version 4. So we have the full tracking history of this abc.txt file on each machine, kind of. This is the simplest way of representing it. So Git is distributed, but it is not having any client server model. Every machine is mastering it itself. It has its own full-fledged repository, and each machine has the option to track the version, right? Simple. This is good. Now let's jump into a bit of the practical. So the most and the first question, how to get Git, right? On most of the Linux system, Git is pre-installed. On Windows, it's very simple. So what you can do, you can go to Google and simply say Git download. The first page, what it opened for you is download Git, and from here you can easily download Git. For example, download Git for Windows, Linux, Unix, Mac OS, right? For me, I'm on Windows, but in Windows we have a Linux subsystem called Ubuntu. So what I did, I have downloaded Ubuntu here onto my machine. So what we can see here, let's say I'm going back here, pwd. So I'm into my home directory, right? So if we need to check Git, then we can say Git ---- version. So just to see whether I have the Git available on my machine. So yeah, the Git is available. The version is 2.511, right? So it means the Git software is available. Now, how to use this software, right? To use the software, the first thing what we need in any software is to initialize the software. It means we want to start the software. Right now, this software is installed, but it's not initialized, right? So to initialize the software or to initialize the Git, what we need to do? We need to init it. So for example, the simple command for it is git init, and obviously we want to initialize this software inside some directory, because obviously, see what Git is a version control system. So we need to control the version inside some directory. So let's say we want to create the parent directory, and we call this directory as my first Git directory, whatever you want to call it, my first Git, right? So what it says, it says initialized empty Git repository in whatever home Hadoop myfist.git. Now let's go here. cd. So when we go here and we say ls-ltr, we haven't found any file, right? So what Git did for us, Git actually created a hidden file called .git. So when I will say ls-latr, it means show me all the files. What we can see here, that okay, Git created one file called .git. Now let's go to this directory, .git. This directory is nothing but our local repository. Okay. So I went to Git again, and let's say I want to see all the files. So what we can see here, Git created some files for us. Let's do one thing. Let's take the snippet of this file system for a time being. So let's take the snippet here and let's put it into our OneNote. Okay, so right now what we can see that okay, Git has created some directories for us by default when we initialize it, right? So I will be discussing most of the directory or file, but we can see that okay, something is called objects, right? In objects we have, and we can see in details, but objects means all the objects what we want to track, trace, or want to commit or something, right? Then let's jump before I go into theory. Let's see here. So right now we have this file structure, right? Now let's say let's go to back again. So I'm into my Git directory. So every time you need to use Git, you need to be inside your main directory, right? So let's say I want to create a new file. Vi my, let's say test.txt, right? So I created one file and I want to insert, hi, this is my first file, right? I created it and I saved it. And I do ls-ltr again. So it means I have one file created for me here, right? Now the question arises, is this file is inside the Git, or is this file inside the Git repository? Let's see. So at any point of time, if you want to see what is the status of your Git repository, it's a very simple term. We can say Git status. So what we can see here, that it is saying that we are on, I will cover this on branch master. So it means, okay, I'll cover it in 2 minutes. But what we can see here, that it is saying that we have some untracked file. The untracked file name is test.txt. Now the question arises, what untracked file means? Untracked file means there is something into your Git directory, but it is not into your Git repository, right? So what it was saying, it is saying that to track this file, please add it to some area, right? So what it is saying, git add file name. So let's see, and again I'll cover it in theory as well. So it says git add text.txt. Okay, I'll cover what add will do, but let's do it. Now let's run the git status again. So what now, see the difference. Previously when I didn't added it to somewhere, and I'll cover you what add means. It was saying that it is untracked file. Now when I added it, it says these changes needs to be committed. Okay, so previously it was untracked. Now it is asking us that okay, there is one new file which is not committed. Okay, so let's go to theory again and let's see what I have did so far and what these command means, you know. So if we go here, in fact, let's go here. Okay, so what we are doing, we have a working directory. The working directory name is my first Git. Okay, so our working directory is this one. So let's copy it and let's paste it here. So we have our working, this is our working directory. Okay, we call it working directory. Into working directory, what we did, we created first file called test.txt. right? And then once we see the git status, it was saying this thing. It was saying this thing. So what it says that, okay, you are on the branch master. So let's cover the branch first, then we will go line by line. See, whenever we work on Git, it will create one branch for you. And now what branch means, and it will name that branch as master. Okay, let me cover again. So whenever you initialize the Git using git init command, Git will create a branch for you and name that branch as master. Okay, and anything you will be committing to your Git, it will go to this branch. Okay, now the branch is nothing but a pointer to the latest commit. Now what commit is? Commit is the latest snapshot. So it means Git committed, sorry, Git created master for you, and this is your branch. Branch is nothing but the committed version, the first committed version, or the snapshot. Right now we don't have any commit, so when we go to the branch, it will be empty, right? In simple terms, Git just created one branch for you. We haven't when we see the hit the status first time, there was no commit. It means there was no snapshot, right? Now since we have created txt file, it says, okay, one untracked file is there which is into your working directory, but it is nowhere else. Git has if you delete this file, Git won't be able to track it, and it is untracked file. Now into Git, right, into Git we have three directories, to be honest. So one is your repo. You know, this is nothing but your .git file, .git directory. One is a working directory. Into our case, working directory is nothing but your my first Git directory. So this is a working directory. But what Git suggests, or how Git works, it said that, okay guys, you cannot commit directly to the repo. If you want to do some commit or whatever, you need to do it in staging first. So right now, let's say we created txt file here, and when we add it, so where it will be getting added? It will be added to staging. And then from staging, once we commit it, it will go to repo. So it will work like this, from here to here, from here to here. Now, the question rises, what is the benefit of this structure? Or what is the benefit of this particular structure? So the biggest benefit is, let's say you are throughout the day from 9 a.m. to 5 p.m., you are working on 15 different files, right? You created 15 different txt file, Scala files, and you added them to the staging directory. Let's say you added 15 files to the staging directory. Now, what is the benefit of adding? Now these files are tracked, right? Now, out of these 15 files, you only want to commit 4 files, because you know that, okay, these files are used, and 11 files are of no use. So this is the benefit you have as a developer. You have a lot of control, which files you need to commit, which files you need to delete, or which files you need to reverse, or whatever. So that's where the staging directory comes in picture. So you can call staging as a rough directory, where you can do your rough work, right? So we came to know that, okay, 3 things, that Git created one branch called master for us for default. Then we have 3 directories: working directory, staging directory, and repository. Working directory is nothing but where you initialize your Git. First, you need to create one file into your working directory. Then you need to add that working file or whatever file into the staging. And then if you want to add something to the repository, you need to commit it. Okay. So right now what we did, let's see the Git status again. So we have added it, but now we need to commit it. Either we can commit it, or we can remove it from the staging directory, or we can unstage it, so that Git will again not track this file. Okay, but into our case, let's commit it. So how to commit it? It's very simple. You need to say git commit -m, and put some message, let's say my first file, right? And the file name, let's say. If you want to commit everything, you can commit everything using dot, but let's say I want to create my file name. So what it will do, see what it did. It says that master root commit my first file. So it used my file. One file change, one inserted. Okay, don't worry about it, but this is what it did. Okay, so now it committed the file. So now let's see the git status again. Ideally, what git status should be showing us the same thing what it should show in the beginning. So it says on branch master. Obviously, we are on branch master, but nothing to commit and work tree clean. Okay, so it means it is committed to the master. Now let's see one thing. We will go to cd.git again and do ls-ltr. Okay, now let me take the snippet again. And let's pair this snippet with our previous snippet. Okay. So I think we took the snippet here, right? Perfect. So what we have seen here now, that everything is same. Branches, hooks, info, refs, head, config, everything is same. It created 2-3 new directories for us, right? So what it says, that it created index for us, it created commit edit message for us, it created log for us. Okay, now, and basically I missed one thing. I will show you another Git directory. Now let's see what is inside each directory. Okay, so let's see what is inside objects. So we'll go to cd objects and do ls-ltr. What we can see here, that inside object we have 3 directories, in fact 5 directories. These 2 directories are of no use to us, but we have 3 different directories, right? In fact, let me show you one thing. Let's do one thing. So we'll go here. So till now, I want to show you one thing else. So let's say we will go for git init again, and let's say test git. Okay, so right now let's go to test git again, and ls-ltr, it should be .git file. So let's go to .git again. I'm doing the same thing, but I need to show you something else. And now sorry, one second. So ls-ltr, and we need to go to test git. Okay, and now ls-ltr, it should be git here. So I'll go to cd.git and ls-ltr, right? So what I'm trying to show you here, exactly, I want to show you what was inside the first snippet. Okay, so let's see here. So it's, what is inside the first snippet? Let's go to cd objects and ls-ltr. So what we can see here, that it has only 2 directories and it has nothing else. But when we go here, we can see that it has created some new directory. Let me do one thing for you guys. Let's go here and go to cd. In fact, let's go here quickly. cd. One second. Actually, I want to compare the 2 directories for you. That's what I'm doing. Okay, so I'm here now. So I'll go to cd. My first git. This was this directory, right? This one, right? So when I go here and I'll do cd.git here. In fact, let's close this. One second. Let's close this. This is our first one, and let's close this as well. So now we have only 2 files open. One is this and one is the old one. So This is our test kit, which I just created, and I haven't done anything. And this is your, in which we have the my test1.txt, right? Let's verify it. Yeah, so is it test.txt, right? So now let's see. cd.get again, lsf and ltr, cd objects, and lsf and ltr. So what we can see here, that it has created 3 new directories for us, right? But when we go for the first time, it haven't created anything. It has only pack and info. Now I need to show you what are those 3 directories, right? So let's do one thing. Let's go to our working directory, that's test kit, and let's create one more file, right? cd vi test1.txt, and let's write something. Let's write hello, only hello. Okay, and let's go to Git again. Let's go to objects. Let's do lsf and ltr. So what we can see here, it has nothing created anything for us yet, nothing, because when we go to git status, so to run this command, you need to be in your home directory. Now when we run git status, it will tell you that okay, test1.txt is untracked, right? So let's do one thing. Let's add it. So we'll say git add dot, right? So it will add everything, not git add. Now let's go to your dot git and dot objects. Okay, and do lsf and ltr. So what we can see, that it has created one directory for us as of now, only one directory. What it did, it only created one directory. Now let's go to this directory, cd ce lsf and ltr. Now what we can see, inside this directory we have one file, and the file name is very long, something 34-35 characters. Let's see what is inside this file. Let us see what is inside this file. It doesn't make sense to us, right? So what Git did, it did something for us, it created one file, but we don't know what this file means to us, right? So let's see now what I want to show you here, how Git stores the data, how Git prevent the data from corruption. Okay, so to do it, let's see what these files are, what these directories and what these files are. So on a very, very high level, what Git do for us, whenever we store some file, so what we did, we created one file test.txt, right? We put hello inside it, and then we committed it. No, not committed, we added it. So for add, it created one folder called CE. Inside that folder, it created this one, right? This file for us. So this is the file inside this folder. Now the question arises, what these files are and how Git is storing the data. So what Git do for you, on any file text, what Git do, Git applies one algorithm that is called SHA-1, SHA-1. So this is the algorithm, and it creates the hash value of the content of the file. It creates the hash value of the content of the file. So hash value is usually 34-bit character. 34 bits actually, 34, I'm not sure, but yeah, 34 or 36. Okay, and what it do, it use the first 2 character of the SHA-1 as the file directory, and the last remaining characters at the file name. Let's see, rather than we remember it, let's do one thing. Okay, so if we want to see the, so what we put into the content, we put into the content is hello, right? This is what we, now what I'm trying to show you here, that what is the SHA-1 object of hello. Okay, so let's hit enter. So what we can see here, this is the SHA-1 or hash value of hello. SHA-1 hash value of hello. Let's go here. Let's put that here. In fact, Control Z, and let's put that here. So what we can see here, that this is, one second, let me find out one thing for you guys. Yeah, it's a 40 character checksum. Okay, it's a 40 character. So it means 2 character out of 40 is stored as a file directory name and 38 characters stored as a file name. Okay, so now go here. So what it did for us, it did something like this. So it created the directory for C and it created one file inside the directory for your file content. So now let's do one thing. So this is the one thing, right? So this whole is 40 character, first thing we know, and this is SHA1 hash, right? Out of 42 characters has been used to create the directory and 38 character are used to store the file name or the file, some file, okay? And the content of this SHA1 is the SHA1 hash came from the content of the file, which is hello into our case, right? Makes sense. Till now, I think we are good. Now, what we can say that it created one file for us when we added it. Okay. Okay. Now before we move further, let's do one more thing. Now let's find out what is the type of this file. We know this is SHA1 file which came from SHA1 hash code, but what is the type of this file, right? To find the type of the file, there is one command provided to us by Git. That's called git cat file -t. -t means type of the file. So to find the file type, you need to go here. In fact, let's do one thing. Git cat -file. Okay, and -t. And now you need to use the full file name. So you guys know one thing, right? The full file name, the full SHA code is this one, CE plus the file name. So you need to use CE and then copy the file name and put enter here. So what we can see here, this is nothing but blob. Okay, so this is nothing but blob. So now we came to know one thing that, and let's increase the font here or bold it. So we know one thing that Git stores your file content as blob. So whenever you add something to your staging directory, it two things for you. Of the file content, it created SHA1 hash code of 40 bits, right? Out of this 40 bits, 2 bits it create the directory, and out of 38 bits it create one file, and the type of this 38-bit file or whatever inside this file is blob. Right? Now let's see if we want to see the content of this file. So we know this came from SHA1. Now if we want to see the content of the file, it's very simple. Instead of -t, just say -p. What we can see here, that inside this blob, we have the content as hello. And we have proved it, that we have stored one file as hello. Git created something called SHA1 hash for 38-bit, 40-bit, use 2-bit to create directory, use 38-bit to create some file. The content of the file is hello. It means whatever we are learning till now is super easy, right? But now let's do one thing. Let's go to our working directory. So we are into our working directory now. Okay. And now let's see the Git status. So the Git status is, okay, the file is added to the staging directory, but it is not committed yet. Okay, so let's do the commit. Okay, let's do the commit. So let's git commit -m. We need to give the message commit. I'm just giving one message commit. Okay, and I'm saying commit this file. So it says one file is committed. Now let's see what is inside our objects directory. cd .git objects and do ls-ltr. Okay, so now apart from CE, it created 2 more files for us, or 2 more directories for us, right? So one is 9a and one is d5. I don't know what they are, but let's see what these are, right? Let's do one thing. Let's go to 9a first, and let's say ls-ltr. So inside 9a, it again created the same thing. So what we can see, one thing is very sure, that it again did the same thing as such a one, some hashing algorithm. It created the 40 byte or 40 size hash for us. The first 2 bytes of the hash it used to create the directory name. The 38 remaining bytes it used to create the file name. We know this thing now. Now let's do one thing. Use this commands again. In fact, let's do one thing. Git cat -file. Let's see the type of the file first. -t, and we are inside 9a, and so what it says, okay, this is tree. So now we came to know that it created something called tree. We'll go to that later, but we came to know that it created something called tree for us. Okay, so we don't know what the tree is, right? Now let's see the content of the tree. Okay, so what it says, okay, what it says that the content of the tree is this. So let's copy this and go to our this one. So what Git did for us, it first created, when we added, it created the file. The second thing what it did for us, it created one more tree inside this directory. It created 9a directory, and it created the tree for us, right? And so this is what it did. So let's go here and let's go here. So we know one thing, that the directory name is 9a. Let's clear this quickly. Okay, 9a, and this is the directory. And inside this directory, we have the content this, right? And the type of this directory is tree. The type of this directory is blob, right? So now we came to know that the content of this directory is this, you know, see now. See, so what it says inside tree is pointing to this particular blob. This particular blob is pointing to this particular directory. So tree means nothing but real tree, you know, like tree structure. So what it says, how Git is storing the data in form of tree. Now we came to know that Git is storing the data in form of tree. The leaves of the tree are blob, right? And whatever the branches are SHA objects, you know. So what it did, it created a tree. Then inside the tree, it created it pointing to the SHA directory and the name of that file. So obviously this means hello, and this hello is stored in this file. So tree is kind of the data structure where the file is stored. What is the name of the file? Here there is no name of the file, right? Here is only the content of the file is there. This is hello, right? The content. But where hello is stored inside test.txt, like Git is tracing this or tracking this in form of tree. So we came to know that it create blob first, then it create tree. Now let's see the third thing. So we came to know this one. Now let's go one directory back, do lsf and ltr. So we have covered what? We have covered the first directory, second directory, and let's go to the third directory. So go to D5, do lsf and ltr. We can again see the same thing, that okay, it again at 38-bit some string, and the directory name is 2-bit, so it means it's again SHA5. Now let's see what this SHA5 means to us, right? So we'll again say git cat -file. Let's first find the type of the file. So we will type the D5 because we need to have the full file name, and then we'll copy this and we'll paste it here. So what we can say, okay, this is commit, great. So we came to know one more thing, that, and let's delete this quickly. So we came to know that it created one more thing for us, that is called, and this is your commit. The type of this particular file is commit. Okay, let's do one thing. Let's see the content of this commit using -p flag, right? Okay, the content of this commit is the message what I gave. And okay, there are 3-4 things. And let's copy this part. This is very, very important. Okay. So inside this particular file, what we can see, this content. Okay. So see now, everything should be very clear to you guys. So this is your first blob. This is your blob, which is created when we edit the file, right? Then we committed the file and it created 2 things for us. The first thing it created is tree. The second thing is created is something called commit. Okay, these are the types. So the type is blob, type is tree, and type is commit. And these are the content. The content here is hello. The content here is this one. Okay. What is the content of the tree? Let me cover again. The content of the tree is nothing but your file name and your blob name. This is your blob name. This is your file name. Now the content of the commit is very important thing. The content of the commit is your commit message, what you gave, right? If you remember here, quickly, what I gave, this is the message what I gave, right? Commit, right? This is the message. So the content is commit. Who committed it? I committed it, your Hadoop tutor, right? At what time I committed it, and who's the committer? Who's the author? Who's the committer? And the most important thing, which tree it is committed to. So this file or this tree is equal to this tree. This blob is equal to this blob, right? So it means everything is interrelated, and everything in Git is stored as SHA-1 40-bit code or hash code. Simple. So now, obviously, these are very, very important thing when we want to track things, right? Now let's do one thing. Let's go to LSF we are inside Git directory. Now let's see one more thing. What commit means, right? Commit, we know that it's a snapshot. Commit is a snapshot of the tree. Tree is the way in which the data is stored, like the tracking. Now let's see how. Basically, we can do a number of commit, right? But which is the latest commit? Which branch we are pointing to? So let's say we want to see which branch we are pointing to, right? So we can say here git branch, and we can say that we are inside master, right? Star means the current branch. We know this thing. Now let's do one more thing. Let's see what is inside this head. So we'll go to cd head. Okay, head is not a directory, so we'll go to vi head. So what we can see here, inside head, we have some reference. The reference is refs heads master. Okay, let's see. So we have inside this particular file, we have a pointer to this. Okay, so let's go to this cd refs. Inside refs, we are going to this heads, and let's say LSF and LTR. Okay, so we have one file called master. Let's see what is inside this file. So inside this file, let's copy this and let's paste it here. Okay, so what we can see, fantastic, right? We can see that our master is pointing to our first commit. So when we see here, this commit, this is our commit, right? And the content of refs head master are same. So what it means that head file is pointing to the committed version of your Git repository. So our committed version is inside this master branch, and this master branch is pointing to this particular committed version. Let's do one thing. Let's prove this point quickly. Let's go here. So let's do one thing more. In fact, let's create one more version. Okay. Let's say I want to go to my Git here and I create test2.txt, test2.txt. Okay, and I write here hello again. Okay, this is good. And now let's do git add, right? Git add, and let's do add again, and let's take git commit again. Git commit. Okay, and this time I will go for commit to. I'll give this message. Okay, and what is the file name? Test2, right? So I'll go test2. Till now we are good, right? Now let's do one thing. Let's go to cd.git and let's go to, okay, let's go here first. Let's go here and let's say vi heads. Head. Okay, and let's see. So right now it's still pointing to the same direction. Refs head master, no changes here. Okay, now let's go to refs head master. Okay, so let's go to refs head master. So we'll go to cd refs heads and let's go vi master. What we can see here, oh, this is changed. This is changed. 1 minute back, it was this one, and now it has changed to this one. So this was your previous commit. This was your previous commit, and now this is your latest commit. Okay, so it means we have proved that every time your head will point to the branch, and your branch refs head or the branch will point to the latest commit. If you don't believe me, let's do one thing. Let's do one thing. Let's close this and let's go here. Let's close this and let's go to two directories back. Let's do lsf and ltr. Let's go to objects. Let's do lsf and ltr. And we can see here, okay, these are our previous directories, which is created for test1.txt. And 3 new directories have been created for us, 13, C9, 2b. Now let's go to 2b first. 2b, lsf and ltr. And what we need to see, git cat -file. And let's see the content quickly. I know this must be your commit. So let's see the content. Okay, so what we can see here, very simple, right? So this is your commit to, which is the message what I put. Who committed it? I committed. Who's the author? I'm the author. Now, see this thing. Who's the, okay, now let me copy it. It is important again, very important. Now let's remove this again quickly. And let's find out one thing. So this is your first commit, right? This is your first commit. Now let's see the second commit, how it looks like. So till now, it is your first commit, and this is the second commit. This is the message which I put in the commit. This is the author. Now when we see here, one more important thing, and this is, and why I'm proving this thing, because it will be very handy. Tree is C9. So when we go here, tree is C9. C9 means this is the tree. How the text2.txt is stored is the information is inside this one. Okay, but when we see here, one more important thing, who is the parent? Who is the parent commit? Like, which is the previous commit before this commit? So what we can see here, this is the previous commit, D5 something. And what we can see here, this is nothing but this. So when you do the first commit, the parent commit is null. When you do the second commit, the parent commit will be the first commit. Let's do one more thing quickly. Let's go here. And let's do one thing. Vi test3.txt. And I say hello again, hello hi again, something like I just need to change the content. Okay, so I will have the different hash. So I'll go here, simple. I'll say git dot, it will be added. Sorry, I again did a git git add this, and I'll say the commit again. This time I want to use commit 3. This is my third commit, and I want to commit my test3.txt. Simple, right? I'll go to .git again. I'll go to, and I'll have an simple cd objects. I will have 9 objects now here. So I can see 2 new objects are created, right? Now let's go to cd 9e and ls-ltr, and we'll say git cat -files. I will say print me the content of which one, 9e, and just copy this one and copy this one. Sorry, git cat file. Okay, so now let's copy this one. What I want to prove that every time when you're committing, your parent will be changed. Let's see. So this is here now. So what we can see here, commit 3, obviously message, nothing, I'm the author. Tree obviously is this one, bb, something like this. See, here should be bb here, bb, right? The tree. Now the parent has been changed here, right? And the parent is 2b, means the parent is this one, 2b. So every time when you're committing, it is pointing to your parent, like the pointing to its parent, and it will point the commit will point to tree will point to the file name, and the content of the file. Okay, now let's draw the structure because this is important. So now we can easily do, right? When you do add and commit, so when you do add, what Git do for you, it will create blob for you, and this blob is stored under, let's say, 2b. Inside this 2b, this is the directory name. Inside this 2b, you have 38-bit hash code value. We can say hash code value. This is 38-bit. When you see the value of this hash code, it means 2b plus this 38-bit blob. It will give you the content of the file, right? Simple. Content of file. Okay, so into our case, the content was hello. It don't know at this point of time, Git don't know what is the name of the file inside which this content is written. So what you do, when you commit, right, you give 2 things. You give a message -m, that is, let's say, commit, and you give which file you need to commit. That is test1.txt. Test1.txt. What it do? Now it create 2 more types of object for you. The first type it create is tree. Inside tree, what it do? It again do the same thing. It create the SHA1 hash of what? SHA1 hash of your file name which you passed here, and this one, this SHA. So SHA, what tree? See, the tree name is the SHA value, we know, right? The first 2 will be here, 9b something, and 38-bit again will be used as a file name. Inside this file name, you have 2 things. The first is this one, let's say 2b and SHA, and the file name test.txt. So what it means, this particular 9b and SHA will came from this content, right? So this is good. Now one more thing what it creates is commit. The type 3 objects it creates, blob, tree, and commit. Inside commit, what it says, who committed it? Author, author, and one more thing is, sorry, one more thing, author and committer. Who was the author and who is the committer, right? So till here we are good. And author, committer, message, and this tree name 9b or something. So we have know this thing. Now let's visualize it. So everything in in Git is a tree, or so what it says, something like this. So we have created text1.txt. Inside this, we have created hello. So it created this SHA1 for it, SHA1 for it. Then we committed it. Then it created tree, which point to this. It again created for the SHA1. And then for this tree, it created one commit. Commit is pointing to this tree. And for this commit also, it created the SHA1, right? And for this commit, what is the latest commit? There is one object called head, right? Head is pointing to the latest commit. This is how the whole structure of your Git has been stored. Like it is how the Git stored the file. So head will point to the latest commit, and head is nothing but refs, head, and your branch name, master. Let's do one thing. So we know that head is pointing to the latest branch. Okay, the branch on which you're working. So let's do one thing. And this is, I think, the second last concept, cd dot dot. I'm going to the base branch now. Cd heads. Okay, 1 second. Cd refs, heads, and I say ls-ltr. So what we can see here, that it has master here. Inside this master, we have the latest commit, right? So it means that master is our latest branch on which we are working. Let's do one thing. To create the branch, we'll create a new branch. Cd dot dot, and we'll say to create a new branch, we'll say git branch. Branch name, let's say my branch is dev now. And to work on this branch, so we have created the branch. So let's say when I go for git branch now, branch. So what you can see, we have two branches now, but still my star is on master. So it means master is the working branch. To change the branch, we'll say git checkout and the branch name dev. Okay, what is it? Switch to branch dev. Now when we say here git branch again, it will again show me two branches, but this time star is my dev branch. What I want to show you now, we'll go to git again, and we'll go to refs, heads, and let's do ls-ltr. Okay, so what we can see here, that we have two branches here. Well and good, right? Now let's do one thing. Let's go to master. So we'll go to vi master, and we can see the master is pointing to 9ec blah blah blah, this one. Okay, 9ec. Now let's go to vi dev. Okay, fantastic. So this time also both branches have been pointing to the latest commit. So what we came to know, that when we create a new branch, it always points to the latest commit. The parent committed snapshot will be used by the child branch. Simple, we came to know this thing. Now let's do quickly one thing. Let's do one thing. One more directory, and let's create one more file, vi test4.txt, and let's say I hello from dev, and let's say git dot, and let's say git commit -m and dev commit something. Okay, we do like this, right? And now let's do one thing. We committed it, and I don't want to tell the story again, but let me show you one thing. cd.git and cd refs, and I want to see that, okay, if we committed in dev branch or the working branch, will the master branch is impacted? Let's see. Dev heads. Again, we can see that, okay, we have dev and master here. Let's vi master. We can see master is pointing to this one. Let's copy it quickly here. And let's go to your dev now. So vi dev. Okay, what we can see, in fact, let me close this because it will corrupt. And let's go to vi dev. Okay, what we can see here, that dev has been pointing to some other commit. Which commit? The latest commit what I did. Now again, I'm proving the same thing and again, that your working branch will always point to the latest commit. Latest commit will point to the tree. Tree will point to your file. File will point to the content. And these everything will be your SHA1 40-bit hash code. First two of these 40-bit will be used in the directory. The second will be used in your file name. Okay, now everything is super clear, right? That okay, this is how it works. Now, why it is Git is storing your data like this? The question. Why? What is the benefit? What's the benefit of using first two character here and then file name here? Why it is doing this processing? What's the benefit? The biggest benefit of this is, see, we know that, forget about SHA. Let's simple hash code. How hash code works? It created some hash table behind the scene. When you do the seeking, what it do? It create the hash code. Let's say hello hash code is 1 2 3 4 5. 1 2 3 4 5. What it is doing? It is using 1 2 as directory name, 3 4 5 as the file name. What is the benefit? So we know hello is this. Now we have some hash function. When we pass hello to it, it give 1 2 3 4 5. We know this thing, right? Now let's say you want to search hello, right? So what you will do? And you don't know where this hello is stored inside which directory. So you have directory like this, 1 2 4 5 up to 1 million, right? Up to 1 million directories. So you will pass this hello to your hash function. It will give you 1 2 3 4 5. Now we know one thing, that these 2 bits will be used the directory structure. These are the directory names. So what we'll do? You will just find that directory 1 2 and you will ignore the rest of the directory. Inside that directory, you will read the file. See, it's the same thing, partitioning and bucketing. So first, it will do the partitioning based on the first 2 bits, then it will do the bucketing based on the 38 bits. This is the only reason it is using SHA1, and the first 2 bits of the SHA code it is using for creating directory, and the last bits it is using for creating file, right? We have almost covered a lot of details of the Git internal. Now let's do one thing. Why we are doing this, right? We are doing this for version maintenance. So now let's do one thing. Maybe the second or third last thing of the today's lecture. Let's do one thing. Let's go back. Let's go back and let me remove my test file. Which test file? Test 4. Let's see. My test 4 is gone. I have only 3 files. Now let's see if I want to recover it. Okay. So what I can do, I know till the time my Git repository is intact, no one has touched it, I should have that file somewhere into my Git. My head should be pointing to my branch should be pointing to my tree should be pointing to my file, and number of things, right? Commit. Now how to get back that file? It's very simple. It's very, very simple. And let's do one thing. Let's see. Yeah. So what I can do, there are 2 ways. And let's try first way. So which file I want to say? test4.txt. Perfect. Oops. See the thing. So I have deleted the file. What I say? Okay, I deleted that file by mistake. Do one thing. Please check out, or please bring me test4.txt. Obviously we know head means what? Head means last committed version. So what this line did for me, it checked out the test4.txt file, which from where? From the committed version. So see, there's so many benefits. I have just shown you one benefit. This is the benefit of your tracking the things. It stored a lot of things for you. So what ideally you need to do, now let's go to best practices, then we'll cover one more thing. So we know internals of Git now, that Git stores everything using SHA-1 40-bit string. First 2 bits used for the directory name, the last 38 bits used for the file name. Whenever you commit thing, okay, so your file, the main file will be stored as blob. When you commit thing, it creates 2 things for you: tree and commit. Commit is nothing but a snapshot. Then there is one pointer called head, which will be pointing to the working branch. Working branch will be pointing to the latest commit. Latest commit will be working towards the tree. Lot of things, right? Now, I don't want to go there, but what are the best practices? So use Git for everything. So we know the benefits now that, okay, if you delete something, if multiple people want to work together, you can use Git. So use Git for everything, data engineers, right? SQL queries, stored proc, ETL, workflow, notes and documentation, everything. But don't use Git for your data. Don't use Git for your data. What it means? It means use Git only for code, not for data. Don't commit anything which is greater than 50 MB. Right? Don't store personal information inside Git. Don't store secrets inside the Git. Secret means your user ID password. Obviously, you will be there will be .config file, whatever different file. If you have those files want to ignore, if you don't want to check in them, there is one file called .git ignore. You can tell the Git ignore, okay, ignore these files, don't commit them, don't check out them. Lot of things. Use branch strategy. I have created dev branch and I created test4.txt. So what it means, use branch strategy. It means that when you want to work on anything new, let's say you are working on some website, right? You want to add a new feature. Obviously, you don't want to commit anything to the main code or the production code. What you'll do, you'll create a feature branch. You will add some code here, then you will commit it once it is tested. So always use branch strategy. This is the most smartest way of working the Git, right? So what are branches? Branches allow you to move back and forth between states of the project. Okay, and branches in Git can be created very quickly because they happen locally. Creating a branch and doing work in a branch is smart because branches allow you to try out an idea, isolate work units, work on long-running topics, share your work in progress with others, right? And this is how branching works. So you have your master here. You created a dev branch, you worked on it, you staged it, and then you committed it and created a new branch from it. This is how branch works. So finally, the last branch you can commit to master. So it means for every change, there is a new branch. So let's say this is feature 1, this is feature 2, this is feature 0. If I want to go for feature 0, you can go from here to here. You just need to check out this branch. Okay. Now, so we know this thing, right? We have repo, your repository, that is .git. We have staging, and we have your working directory. This all is in a local machine. Now, let's say if you want to share this work with, obviously, you have 100 people working in your team, right? The last topic for today is how to share this work to some remote repository. So this is your local repo. If you want to share your work to somebody else, you need to share this work into some remote repo. Now, one important topic, what is remote repo and what is remote repository? Which companies are providing these remote repositories? Now let's learn about it. So you guys must heard of something about GitHub, Bitbucket, GitLab, right? So see, behind the scene, we know that they are using Git as a software. Now they have provided the remote repository for us. So now let's see the difference between first the Git and Git bucket, right? Bitbucket, Gitbucket, whatever you want to call GitLab. So I will cover this thing. And okay, GitHub on the other hand is the website or user interface that allow users to access Git on the cloud and also store their project repository on the cloud. Simple, right? It's something remote on where we can store the code. So let's go quickly into the GitHub. So what we can say here, github.com. Okay, what GitHub Okay, so basically I just created an account for me. But if you want to create the account, it's very simple. So once you go here into the, first you need to create a GitHub account. Now you need to create repository, right? Everything in Git or into version management, distributed, everything is a repository. So let's do one thing. Let's create a new repository. Let's name this repository as Spark Kafka integration, something like this. Okay, it's not working anyways, so let's create Spark Kafka, something. Okay, and I don't want to do anything. Let's create it. So what it will do for me, it just created one repository for me. Now what I need to do, I need to see, this is on internet, this is on website. Did my local machine Git know that, okay, there's some repository called Git Kafka or Spark Kafka? No, right? I need to point my local machine to Kafka. Okay, let's do one thing. In very simple term, let's do one thing. I'll go here. I do one thing. Let's say Control C. It will give you the command, and I'll explain the command. So what I'm saying now, okay, git remote add, and we can name anything here. So let's say I want to add my GitHub. Okay, I'm just telling my Git, add a remote repository. The URL of the repository is https GitHub whatever, and name that remote repository as my GitHub. Okay, now hit enter. So what it did, now let's say if I say git remote, what does it say? Okay, there's one remote repository available, that's GitHub. Now let's say if I want to commit these 4 files into that, what I need to do, I need to use push command. Push means push something from my local to remote. So how push command works? So let's copy this again and go here. Okay, push works like this. First of all, you need to give your remote branch, my GitHub, into my case, my GitHub, and then you need to say from where you need to push. Into my case, I need to push from Jeff. Now it will ask me for my user ID and password. So my user ID is your Hadoop tutor, and my password is this one. Perfect. Now let's see here, and let's refresh this page. Oops, we have all the files here from where? From my dev commit. And everything is so simple, right? And this is now let's say I want to pull these files somewhere. So what it is saying me, okay, let's do one thing. Let's copy this again, and let's open one new window, and let's consider this new window as some other developer, right? And let's say if I want to copy the content again here from my remote repository, what I'll say, git clone, and this one, cloning. Perfect. And I'll do lsf and ltr here and see. 1 second. So I'll go to start. It is the branch name. What is the branch name? It's Spark Kafka. I'll do lsf and ltr, and I can see all 4 files here. So this is how you need to pull code from there. You need to create some branches and different kind of stuff, right? So let's wrap up quickly all the things what we have covered so far. So commit is nothing but a snapshot, right? And commit is a verb. Commit contains 3 pieces of information: reference to the previous commit, parent commit, hash code, something like I have covered it. We have covered all the commands. Best practices we command, branches we have covered, and then we have covered this as well. So this is what we have did. So this one is your local one. And we have created my GitHub, and from my GitHub we have pushed into our GitHub. right? GitHub remote server. This is what we did. Okay. Then we have covered this one, this, everything. One thing which I need to cover here, and which will give you a lot of confidence, the good news. As an end user, you do not need to worry about all the things what I have told you. You just need to use these 8 to 10 commands. Simple. If you know the usage, what I have shown you, git init, git status. Okay, let's show git log, right? Let's see what git log is. So if I go here into my this machine and I'll say git log. So what git log will be showing? Whatever I have did till now, it will show me the log. Okay, first of all, I did the commit. Inside this commit, I have committed this version. Then I did the commit 2. I created this snapshot. I did the commit 3. I created this snapshot. I created one branch and I did this snapshot. So dev will show me everything. And then what I did from head to dev, and then I pushed everything to my GitHub dev. So log will show you everything, right? Then I've used the git add, git commit, git diff. So basically, when you these 3 commands are interesting. So when you want to see the difference between two repositories, you can go for the git diff, git rm, and git move. Git mv is to rename the file into git. Git rm is to remove the file from the git. Okay, to be honest, these 4 or 5 commands will do the work for you. Okay. So this is how Git internal work. Everything is SHA 140 byte hash code inside. Out of these 40 byte, 2 bytes is stored as a directory name, 38 byte is stored as the file name. There are 3 types of file: blob, which is your real file; tree, which is nothing but the tracing of the file; and then commit, which is the snapshot, right? Blob is your file content. Tree will be your pointer to this file. Commit will be your 3 things: pointed to this tree, and parent commit, and author and committer. Everything works like this, and this is how the real things works. And this is what Linus, the developer of Linux, did the things for us, you know. So I think a very intense lecture, but do comment, do like, please subscribe the video, and thanks for all the support, guys. Really appreciate it. Thank you.